Okay, so what we are seeing here is the execution of code. So it's halted at main right now, and we will press F8 to run it. So the program is running right now. It's executing, but we can't see it. But soon it will halt at a breakpoint which I have set for before turning on the green LED for 1 second. So what we want to see is memory browser, and we will put the base address of bank 1 here, which is 0x20,000, and we will see that pattern which we have used for 2323 is filled into this memory area. It's quite a long area, so we will just see this pattern repeating over and over again. Also, we'll just see how does it look at 30,000 address. So this is the 30,000, still it is the same. And now I will go to 3FFF values, the last sectors. As you can see, yeah, this is the end of the flash main memory, and as a 40,000 addresses start, it's no longer a main memory sector, but something else. And yeah, so up to the address 3FFFFF, we have the same value. Now we will start resume the execution and turn on the green LED for 1 second. Yes, as you can see, green LED was turned on for 1 second, and yeah, this is the debugging mode code execution. Now we will see the normal mode code execution. So what I have done is I have set the countdown timer, and we have started it just as the green LED blinked, and we will keep waiting for 1 minute for it to blink again. So it will wait for 1 minute to complete and then run again. So ideally, the distance between blinking of green LED should be around 1 minute. The starting green LED might do again. Now it's countdown: 5, 4, 3, 2, 1, 0. Okay, this is just human error, but it works exactly at 1 minute. And now I pressed the red button and it was reset. I have not pressed it yet. It's green LED, so completed. I pressed it short for a short period of time, but it does not reset. Now I will do a long reset where it will turn up the red LED and it indicates the system has been reset. Now we will see how the code works in CCS IDE. That's where the next section will take you. Okay, so now we will see how the code works here. Let me figure. Okay, so now this is our main.c program which is running on MSP432 Launchpad. So first we have defined two constants, which is bank1 start address, which is 0x20,000 in hex, and 4 KB length, which is 1000 in hex. After that we have field data, which is array of type unsigned integer of 8 bits, and it is length of 4096. That will make it 4096 bytes because this is 8-bit data type. The size of this array will be 4096 bytes or 4 KB. and this is a start address and some variables. This is a volatile variable, so it can keep changing. After that, we have some method declarations, and these are not the definitions. The definitions are coming afterwards. And here our main method starts. So first thing we do is to uh, hold the watchdog timer, and then we go ahead and set the frequency of DCO clock to 48 megahertz, and we initialize the master clock with DCO clock. So our master clock frequency will be 48 megahertz, and we set the core voltage level to V equals 0. That is just a power mode. After that, we blink the red LED for 1 second. So whenever the system is reset, it will first blink the LED for 1 second. So here is the code. We set the pin as the output pin, and we set the output high on that pin. We have a delay of 1000 milliseconds, and then we set the output to low. So we'll just see how the delay function works. It multiplies the millisecond into 48,000. That is the number of clock cycles per millisecond, and we divide it by 36 because the for loop requires 36 clock cycles to run for one iteration. So that is for turning on the red LED for 1 second. Then we set the port pin 1.4 as a digital input pin, and we use flash control set wait state for both the banks, so it's faster for programming of flash. After that, we generate the fake data to fill inside each sector, and we are going to use pattern of 0x2323. So we put that fake data into filled data array. After that, we continue with our setup, and we disable all the interrupts before we are setting up the timer module and watchdog module. So we initialize the timer 32 module with these two parameters, and uh, so we say that the it's a periodic mode, so it will stop once once it is completes the run down. As you can see, uh, it is not a free run mode, so it will not start again from max mode. It will halt at 0. Then there is a prescaler. So now this prescaler actually makes the timer 32 clock slower by multi dividing the clock module, and we use 32-bit mode, and we are configuring timer 32 0 module. So we have two modules, 0 module and 1 module, but we choose to use 0 module. After that, we halt the timer, and we continue ahead with configuration of watchdog. So for watchdog, we will use another clock, which is a reference oscillator clock, and we will copy the 32 kilohertz frequency which we have set for refo clock to SM clock, because the watchdog timer cannot directly use the refo clock. We want to use it through SM clock, and we initialize the watchdog timer with 32k iterations. So it is exactly 1 second because we have 32 kilohertz frequency, and watchdog will count up to 32 kilohertz, 32 kilo cycles. So it will come down to 1 second. After that, we enable all the interrupts because we have uh, completed configuring the timer, and we enable the master interrupt. Another thing about watchdog is we set the timeout reset as a hard reset. So sets the type of reset that happens when a watchdog timeout occurs. So you want it to hard reset uh, against the soft reset. After that, we have a while loop. This while loop will keep running indefinitely unless and until a hard reset occurs. Maybe because of watchdog or power turn on off or something like that. So when this while loop starts, first thing we do is set the timer 32 for 1 minute, and this is a number which comes by multiplying 48m, that is 48,000 into 60. After that we start the timer. We start the watchdog timer also, as we are into normal execution mode, which will keep on going forever unless someone interrupts it. We set this flag, wait for 1 minute to complete to true, because the 1 minute is not yet complete. We will see ahead how this flag is used, but for now we will keep it true. And then we will have a sector number is equal to 1 and start address as a bank 1 start address. This is just variable which we will use in this for loop, which will run 32 times. So what it will do is it will unprotect the sector. It will reset the watchdog as some time has passed. It will erase the sector, again reset the watchdog as some time has been passed. It will program the flash memory with filled data which we created previously here with 02323 pattern. And again some time has been passed, so it will reset the watchdog. It will change the start address and add 4000 because we have already written 4000 bytes. And then again after writing it, it will protect the sector and reset the watchdog. After this for loop completes running for 32 times, we will turn on the green LED for 1 second as an indicator that flash reading and writing is complete. And then we have a while loop. This while loop checks if wait for 1 minute to complete is true or not. So as we have set it true here, this should go on forever, and it should just keep resetting the watchdog forever. But it doesn't happen in that way because we have set up the timer 32 for 1 minute. So after this 1 minute completes, after this instruction has been executed, timer 32 ISR will be called. And what timer ISR will do is it will clear the interrupt flag and it will set this variable wait for 1 minute to complete as false. So this while loop will be executed and we will come back to upper level while loop, which is an indefinite while loop which will go on forever. So again it will start to set the timer for 1 minute, start the watchdog, execute for loop which writes 32 sectors of 4 KB length, and come back again to wait for 1 minute to complete. So again wait for 1 minute to complete will be set to false when the timer 32 ISR is executed and control is given back to main function main. So another thing which we need to see is how we reset the watchdog. In many places we have put this instruction of reset watchdog. So what happens is that when we call this function, it will check if pin port 1.4 or pin 1.4 has a high or low input. If it is high, it will just return and not do anything. Otherwise, it will clear the watchdog timer. So when the button is pressed, whenever this reset watchdog is called, it will not reset the watchdog timer but just skip the execution and return the control back to calling function. So this is how the reset works. We will see how other methods are working, like green LED for 1 second, because green LED for 1 second mm, runs in the context where watchdog timer is running, it will not take the 1000 millisecond delay as red LED for 1 second takes. It will take 500 millisecond delay, then reset the watchdog again, 500 millisecond delay again, then turn off the port green LED and then reset the watchdog. So just as a standard practice, I am resetting the watchdog whenever I'm exiting any method to give enough time for calling function to reset it again. Another code file which we must see is a startup. Here I have changed the interrupt vector table. So what happens here is I have set timer underscore zero underscore ISR method as a hint as a ISR to be run when timer 32 interrupt 1 happens. This interrupt occurs. So I have declared it here in the same file. So it's just a declaration, not a implementation. But in main.c, I have implemented this function which will clear the interrupt flag and set wait for 1 minute to complete to false. So this is an overview of code, how it works, and yeah, and this is me, Meet. Hi.